Okay, I am recording. Welcome, Coulter. So if you missed last Wednesday, open up the HyperDoc and there is a link to the video, and I'm gonna finish that up today. We talked about most of the stuff then. I don't wanna repeat all of it. We will go through some of it fast. There is an assignment. A lot of that assignment is just answering simple questions. So I would recommend you go open up that assignment and open up the book also to 315. And in the assignment, there's some simple questions.
Wait, is it the assignment that we did last?
It's the assignment that you already turned in, Lyndon, although you should feel free to reopen it and improve it.
Yeah.
Must be in the, okay, must be in the slides. There we go. Right, so like one of the questions is, what are categorical variables? Right, and another question is, what are quantitative variables? Simple things to answer. They're right here in the introduction in the slides. So it's not a super hard assignment. I'm trying to show you guys the power of Python in dealing with data. And we got through most of it on last Wednesday, and we're going to finish up today. And I got 6 students here, and I only marked down 5. I didn't mark down Maria. Oh, no, I didn't. Maria. Okay, it is 4 after. Let's start going through the agenda. Right, so this is the last day on Unit 3, the last day on Lesson 3.1, Visualizing Data. We're going to finish up with histograms and distributions. And yeah, if you need to chat about something, right, you can either hang out after class. I'm going to help Adam today with a little bit of his code, or you can always follow the link for you can book me in the agenda or in the HyperDoc. I've only gotten 4 videos and written responses submitted. So at this point, right, remember they are due next Tuesday at 11:59 p.m. East Coast time. Let me write this down. AP portfolio due Tuesday, May 26th, right? 11:59 p.m. EST, which is 8:59 p.m. PST. Machines get slow, so don't do it at the last minute. Right, so try to do it on Monday if at all possible, or at least Tuesday morning. Don't wait. In Google Classroom, for people who weren't here on Wednesday, I linked a web page from AP, which is a walkthrough on exactly what you need to upload your stuff for them. Okay, so that link is, I can copy that link and paste it into today's agenda. AP's walkthrough on how to submit is here. Okay, oh, so when you guys get done this week, do not wait for me to match you up with somebody else to review it, right? Just reach out to one of your classmates saying, hey, my video is done, my written response is done. Can you go use the rubric that Benoit posted in the assignment and give me feedback, and offer them to do the same thing, right? And it usually only takes like 15 minutes to give somebody's feedback, right? So do your best. So be nice, say yes, you'll do it right as soon as possible in the next hour, literally, and give them good feedback. Okay. Essential questions. I went through all that stuff last week. You guys will watch the video, you'll see it there. For people who weren't here on last Wednesday, last Monday, I said our final was going to be Python data analysis. I forgot that I wanted to get into simulations. So our final is actually going to be modifying a virtual world, a virtual thing in NetLogo. I did give a demo of that, I think, last maybe it was just last Wednesday. I'll give another demo this Wednesday of it. There's tons of stuff there. It'll be fun. It is not super stressful, but it is a little bit challenging because it's in a brand new language that is a little wonky. And I will explain how it's wonky, but you'll have fun. It's a cool thing to do. We are going to finish up activity 315, which is the last part of, this is actually histograms and distributions. Okay. There's the hyperdoc. I mentioned the assignment. I highly, highly, highly recommend opening up that assignment, taking notes as you're listening. You can probably get most of it done by the time we're done. In Classroom, I also posted a new Python file. So this is based on the histogram age income that PLTW gave us, and I modified it to do box plots as well, and we will see that in just a second. Okay, so last time in, sorry, I need to edit something here. Last time we were talking about histograms and distributions, and kind of what's the difference. Where is my run button? Let me stop and run. Okay, right, so these are histograms. Histograms are a specific type of bar chart, right? So a bar chart is the generic thing where you're using these rectangles, these bars, to show data, and a histogram is then a type of that bar chart where you're taking the entire population and breaking it into buckets, and then charting those buckets. Okay, and in histograms, they use the word frequency to represent the count of anything in that bucket. So on the left, this is the histogram of age distribution from 2014 census data, and on the right, this is a histogram of income from the 2014 census. This one has a lot more bars. You can control that. And it's just, how much data is there? Are more bars helpful or not? Then we talked about different types of histograms. Let's see if they have that in here. No, it's further down. Okay, right, so this is kind of what I was showing you in Replit, which are squished down. These are bigger views of it, same data, right? Our information is usually just a list of data that we then count up into these ranges or bins or buckets to get a frequency, right? So frequency is just a special word in statistics when they talk about histograms, which means how many items are in this bin or in this range. Okay, so it just means count of, right? So there were, and this is in thousands of people, so there were 2,422,000 people in the 2014 census who were greater than or equal to 15 and less than 25, right? So 15 through 24 years old. We did that. Let's talk about distributions. I think it's in the back of this. I'm going to transform data. Sorry. I'm looking for their distribution pictures because that's kind of, there we go. Okay, so so those of you in calculus, you would probably kind of recognize this red curve, and this is if we made a plot of every single little age, right? You are 1 day old, 2 days old, 3 days old, 4 days old. You would get a much smoother curve here instead of these bars, right? So that would be kind of a continuous distribution versus a discrete distribution is where we have these big buckets and you see these step functions, right? So it's kind of like analog versus digital, continuous and discrete. Continuous is analog. There is no necessarily break between the data. just mark Mr. Garcia here. Right, categorical are things where we're dividing the groups based on a value, like a zip code or a hair color, that there's no necessarily meaningful order, right? I could sort zip codes by number, but that has nothing to do with where they are, right? It's difficult to sort them by address because, right, it's a two-dimensional space. Lots of things. I'm not going to get into samples and populations. This isn't doing distributions either. I missed the distributions. So in distributions, sorry. It wasn't in there. I'm looking up an example distribution. Example histogram distributions. And the reason is those, it ties into box and whisker plots that we're about to do. So this is kind of, so this curve, this is kind of the classic Gaussian curve or bell curve that we expect a population to typically follow, or a random distribution to typically follow, right? A lot in the middle, thinner on the ends. Okay, you could have a distribution that has two peaks, right? And that we call bimodal. If there is a bucket that has a high count in it, that's the mode of a distribution. So in this guy, the mode is this bucket, is this bin with the highest number. If we have two bins with either equally high or close to equally high, we call it bimodal. And then there's skewed, and a skewed distribution is when there's a longer tail on one side than the other side. So this distribution is skewed right. Okay, you could have a distribution that's skewed left. You could have a random distribution, right? So we use words to describe distributions because that usually has meaning to it. Now, there's other ways of plotting this data that probably a lot of you haven't seen unless you're in statistics, which are called box and whisker plots. And I want to show them because they are a cool way of also seeing data that's not quite as visual. Oh, really? That's not quite as they're very visual. It's not quite as intuitive. Darn it. I thought they actually had a good explanation here of what a box plot was. Okay, so I am not going to use that. I'm going to have to add one. Box whisker plot. So I just want to show you guys the standard definition first, and then I'm going to show you, yeah, I can use an image. That's fine. Okay, so a box and whisker plot, they used these a lot before computers when they were trying to do like newspapers or things where you could do it with a typewriter or without fancy graphics. So in a box and whisker plot, you have two boxes and then a couple of lines, right? So it kind of looks like, you know, a cat's face with whiskers. That's why they call those whiskers. And everything has meaning, okay? So the lower box, or the box to the left, is the bin from 25% of the population to 50% of the population, right? And then the next box is from 50% of the population to 75% of the population. Let me open that in a new window. No, sorry. It's not what I wanted. We'll stay here. Right, so sorry. So this box is 25 to 50%, this box is 50 to 75%. So you can see from these two boxes where half the population is, right, where the exact median is, right? And then the two whiskers, the one to the left or to the bottom goes down to 0, the one to the right or to the top goes up to the 99th percentile, not quite 100. You can force it to be 100 if you want, but usually we do 99%. So that kind of shows you, are you symmetric or are you maybe skewed right? So this would be a skewed right distribution. There is a longer tail on the right. Okay, so it kind of shows everything. I can rip this page off. If I put that there and come back to PLTW, sorry, this presentation is not more organized. I thought I had everything I wanted in the book. Where did that picture go? There we go. Okay, so, right. This picture is showing us, right? It's showing us the peak. It's not showing us necessarily the median. We could kind of figure out the average or the mean value in here, and we can kind of see, you know, where 2/3 or 3/4 of the people are. The box plot gives us very precise information on the median, where the 25th percentile is and the 75th percentile is, and then 0 and 99. Yeah, so that's a box plot. Now looking at that same data that we've been looking at for 315 in Replit, okay, we can do a box plot really, let me show you the code. If you have code that will do a histogram, it is simple to do a box plot as well, right? So here's their code for doing histograms for some different plots, each of one. So I converted it to do a plot of 2 together, and then I added in the box plot, so it became 4. Okay, so I'm kind of highlighting the changes versus histograms. This file's in Classroom. This part is the same, except I had to change the name of the variable from AX, right, to be AX0 and AX2 or whatever. So here it is creating the histogram. Well, here it is creating the box plot, right? As long as you have the data, it's as simple as just, oh yeah, plot it this way, plot it that way. Give me a plot that's a histogram. Give me a plot that's a box plot, right? And Replit can do it really fast. So here is our, I put that code into Replit. If I turn off the histogram one, turn on the box plot one in main, right? Because in Replit, when we click run, it always runs main. So to switch between files, I just have to import the other file that I want, and I run it. It will do it here, and it's kind of squishy. It's a little difficult to see, okay? So I have that same code in Microsoft Visual Studio, which is what I mentioned before as being a great coding environment you can run on your Mac or on your PC, and what we're switching to next year instead of Canopy, because it's much better and it's more stable and it's going to be supported. So here's that same code. Instead of putting them one row of 4 items in Visual Studio, I made it 2 rows of 2 items each. And when I run this, here's the output we get. So here's the histogram for the ages. Here's the box plot for the ages. Okay, right, so it's showing us that 25 to 50% of people are kind of in the 40 to 55 range. And then another 25% of people are in the 50-something to 60-something range, right? So that's kind of saying, okay, well, here from this about here to about here, that's 50% of the population, okay? So on a histogram, you have to kind of eyeball that and guess. On a box plot, it's telling you exactly where 25% is, exactly where 50% is, exactly where 75% is. And then it's giving you these whiskers down to 0 and up to 99. And it's supposed to give you little X's or some symbol for any data that lies outside the whiskers. We don't have that for ages here, but we do have it for income. Now look at the income plot, right? There's a peak on the left, so it's right skewed, right? But it's kind of tough to see, well, where's the median income and where are most people? So if you look at the box plot, that little box down here, the tiny one lower than the orange line, that's the people who are in the 25 to 50th percentile of incomes. And they're down here, and this is income. Yeah, I haven't figured out how to fix the labels. So this is income between 0 and $1 million. Okay, so that's 1E6. So that means 1 times 10 to the power of 6, 10 with 6 zeros, right? So that's 3 is 1,000, 6 is 1,000,000. So this is $1 million. So most of the people, most of the households are down here, probably in the, less than $60,000 range. And then you have another 25% that's in the $60,000 to maybe $80,000 range. Okay, 99% of people, of households, make less than 200,000. So that's 20,000, that's 40,000, 60, 80, 100, right? If it keeps going, there's a bucket over here that's 200,000, but the incomes keep going up. There's this crazy tail of people making all the way up to $1 million and even higher. Okay, this box plot to me shows that a lot better than this histogram. Right? It shows that the vast majority of people are down in this one section, and there's a super long tail that just keeps going. Okay, so that's one nice thing about box plots. If you're ever doing something and you need to produce a graph for it, if you think histogram, while you're there doing a histogram, do a box plot at the same time, because sometimes it gives you other data. Or if you need to show 7 histograms on a screen, it's actually easier to put 7 of these box plots next to each other in this, in a smaller space than you could get 7 histograms. So box plots are great because they show you super long tails better, and they allow you to, to put a higher number of them in a small space. So if you're really trying to dig into the data between different groups, it's easier to compare and contrast. Okay, that's box plots. Python can do it ridiculously easy. Let me come to the code here. Right, here's the one line for doing a histogram. Right, here's everything. Right, and then there's a title, and there's an X label and a Y label, and there's adding some PLTW styles onto it, which I don't care about. Right, but that's the line that does the histogram. That's the line that does the box plot. Right, if in Python, if you can do a histogram, you can do a box plot. Just plug in the same data and let it run. You don't need to send in colors and bins. It'll do something. Okay, I can take out this auto range and it would do something too. That was it for 315. So the assignment is you guys are supposed to go in there, answer some questions, and tweak that histogram, understand what bins do and what is it, how do I control it? Is more better or is it not better? And in what case, why? Right, so 315 is just kind of get into the existing code, and that is in Replit. So if you go to the Replit classroom, if I come to teachers, Replit classroom, right, you need to join our AP CSP Python 3 class, because that's where we can do this plot stuff. And projects there, right, there's a project for 311, there's a project for 314, there's a project for 315. Open up that project and you can play with that code yourself. If you want to check out the box plot code, you can grab that off of the attachment to today's class. Box plot age income, copy that, paste it into, add a new file, paste it in there, and you could run that one instead. Any questions on, first, do box plots and histograms provide similar data? How do I do this? I need to like Pear Deck or something so I can get you guys to click a button and give me feedback. Right?
Yes.
Alex said they provide similar data. Does anybody disagree with Alex?
No. Can you repeat the question?
Do box plots and histograms provide similar data?
It does.
They're just kind of different ways to look at the data,
Exactly.
but they're still the same data.
Exactly. It's the same data plotted in a different way. I think box plots are less intuitive because we're used to seeing graphs where, you know, the height of something, it's an XY graph, the height of something says how many are in there. And this is showing you where a range is, and the whole height is kind of then the how many. And you have to then understand that.
Quartile and the upper quartile and all that.
Yeah, so this is the second and third quartile, right? And then this is the first quartile, and this is the fourth, almost the fourth quartile. It only goes to 99%, right? So it's another way of doing it, and sometimes it is more powerful than a histogram. So I just wanted to, right? If we're going to talk about histograms, we should talk about box plots and their power as well. Whenever you do one, you should do the other one, because it's simple to do. It's simple to do in Excel. It's simple to do in Sheets. It's simple to do in Python. So if you're doing one, do the other one, see if it tells you anything. And if you have to present a lot of histograms for some reason, use box plots. At Intel, we used to use box plots all the time when we were doing manufacturing and trying to improve how many chips we were getting out, either working or at what speeds. We would take different runs through the manufacturing plant and compare how many good parts we were getting, or what speed ranges we were getting versus some other parameters. And we would have all this data. It's like, oh, this one right here, that was really nice. What's going on there? Let's try to get that one to be, let's tune everything for that one to be more common. Okay, that's all I got for today, right?
Benoit, where did you get the other data, the age distribution?
That is all in 315. If you run 315, this is what I didn't like about Replit, is if you run the, sorry, I try to keep the participant thing open. There we are. I want to open histogram. So in their histogram one, at the very bottom, maybe this is too big. They were producing two separate plots, right? So they had like figure age and fig income. And then they threw them to the screen at the same time, and it depended on whether it actually showed both of them or not. So if you can only see one of them, look at the label to see which one it is, and then go comment that one out. Or it's simple. I took the code, right? Go grab the box plot code and just paste that into a new file and run that, and that will give you the set of 4.
Okay, and then you just want us to edit that somehow, right?
So yes, you're gonna look at it. You're gonna play with the number of bins for this one, right? And see, okay, well, you know, if I set, so bins is 200. If I set it to 1,000, what does that give me? If I set it to 100, what does that give me? What's a nice number of bins for this data from my point of view?
Okay.
Okay, right, and I'm just trying to, a lot of times in computer science, you're given somebody else's code that does something, and you need to add something to it or tweak it and make it better. And so this is just kind of, plotting in Python is really easy, especially if you can zoom in on, you know, what's doing the work. And I made the font here ridiculously large. Right, so here's the part that does all the work in Python for doing the plots. And if we ignore setting the title and label, that's how you create a histogram. It's actually pretty easy. It's simple to play with the bins. And here's doing the income histogram. Oh, it's simple to play with the bins. I can do that.
Okay.
Okay.
All right.
That is it for today. Please do call in on Wednesday. We're going to talk about the final project in NetLogo. But use the next half hour to, if you haven't finished the 315 work, to go finish it. It's straightforward, it's easy, it's fast. Go do it. If you've been missing a whole bunch of stuff, look through a whole bunch of work in this class recently. Look through the 311, 314, 315 code. See if you can understand them. If you can get them done really quick this week, before Wednesday, do them. But then focus on the final project, okay? If the final project is better than your current grade, I can improve your current grade. If you work on 315 and it's better than your current grade, it moves your grade up a little bit, right? But the final project is this big reassessment. So if you're behind, don't worry about that stuff. And my God, if you're not done with your AP work, go do that. Hang up right now and go do that. Okay.
Okay.
That's all. Adam's going to hang out. We're going to talk about his problems, but I shouldn't say his problems, his code for the AP Create stuff. We might talk about my problems, but that's it. If you want to chat with me to get help on something, use that. You can book me link to pick a time.
All right. Later, Benoit.
See you, Miguel.
Later,
Oh, no.
Benoit.
See you, Maria. See you, Alex.
Bye, Benoit.
Bye-bye, Benoit.
See you, Eduardo. See you, Luis. See you, Long. Let's see. I'm going to stop sharing, Adam. So when you get on your computer, you can start sharing.
All right.
Oh, I should stop recording.